Okay, so today we're taking a look at happy number, which is Leet code 202. The question is write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number with the sum of digits. So any positive integers over here is the input n. Replace the number with sum of squares of its digits and repeat the process until the number equals 1, where it will stay, or it loops endlessly in a cycle which does not include 1. These numbers for which the process ends in 1 are happy numbers. Return true if the number is happy and false if not. So basically, you take a number, you divide it into its constituent digits. So if it's 121, if the number is 121, the constituent digits would be 1, 2, and 1. So you do 1 square plus 2 square plus 1 square again, and that will give you 1 plus 4 plus 1, which is 6. And then you take 6 into 6, which will give you 36. And you keep going like that. So, and in the end, if you reach 1 somehow in some step, when you keep going, it's a happy number. And if you don't reach 1 and you keep going in an endless cycle being the important word, uh, then it's not a happy number. So basically it's very easy to find out what if the number is happy, because eventually it will come down to 1. But if it is not happy, then we have a problem, because it will endlessly go into a cycle. So I told you cycle is an important word. That is exactly what we want to do. We want to find out if a cycle occurs. And how will we know if a cycle occurs is if there is, say, 1 and then we get to 5. This is not like the proper method, but if we go to 1 and then 5 and then we get, say, 6 and then we get 1 again, so now we know after 1 again there will be a 5. So that is a cycle. So we need to find out if there's a cycle. So to do that, what we will do is, first we will write a helper function which will just give us the square of the individual numbers separated. So ints will have the sum, and we need to separate out all the digits. B will do that. We will have b equals to n mod 10, and we will remove the last digit of n. Oh, sorry. And we will also need to add this to the sum, add the square of that number to the sum, and we can return s, which is the sum. Okay, so now inside the actual function, what we need to do is we will use two pointers. One will be slow, so there'll be a slow pointer, and there'll be a fast pointer. What this will do is the slow pointer will move one step at a time, and the fast pointer will move two steps at a time. So slow pointer will move one, fast pointer will move two. Then slow pointer will move one, fast pointer will move two. Again, slow pointer will move one, fast pointer will move two. So basically what will happen is, once there is a cycle, the slow pointer will be at one end of the cycle, at one point in the cycle, and the fast pointer will be in a further long point of the cycle, and then again cycle back and come back to the same point or behind the slow pointer. So what will happen is, what we can check is if the slow pointer and fast pointer are same at any point. We can prove this if you take a like just keep solving the progression for a number that is not happy. You will find that there is a cycle. And if you have this kind of a progression where you have a slow pointer moving one step at a time and a fast pointer moving two steps at a time, then you can prove that the slow and the fast pointer will move at one point of time. So when it meets, then we can check if the meeting point is 1, then it's a happy number, because we know that the happy number will converge at 1 and stay at 1. But if it's not at 1, then we know it has converged at some other point, and thus it cannot be a happy number. So to do that, we'll have slow equals to square sum of slow, So here you can see the slow has already been given the value n, and fast will be square sum of square sum. This is the important part where we are calling square sum twice. So square sum of fast will give us the square sum of fast, and then again we are running square sum of fast on that. So basically when slow will run once, fast will run twice, and this we will keep doing till slow is not equal to fast. In either case, whether it's a happy number or not a happy number, slow and fast will converge. If it's a happy number, then fast will be equal to 1, then we can just return true. Otherwise it won't be equal to 1 and we can return false.